that I'd like to talk about is the sustainable retrofit. This is more to do with the energy consumption of the existing building. So in Hong Kong, majority of the buildings, like 90% of the building stock, are classified as existing building stock. I suppose those new buildings are not much an issue because they are built of the latest building standard. I suppose they are very, very environmental friendly. But for the old buildings, their standard is much lower. So how can we retrofit those buildings becomes a very big issue. Those are not very, very energy efficient. This is a guideline produced by OVRA in Australia, showing the different sustainable retrofit solutions. So there are some solutions which are more suitable for high-rise buildings in urban area. So I've listed out 67 of them, and those are published in one of the papers that are published in Renewable and Sustainable Energy Review. 67 of them are more relevant to Hong Kong. And this is another table made by IPCC showing the retrofit solution for different climate zones. They look at it from the technological aspect, the cost aspect, and the appropriateness. The appropriateness is to do with the probably the human behavior. So when you think about the high-rise building, like those in Indonesia, in Hong Kong, those are occupied by tenants or owners. If you want to do a sustainable retrofit, you cannot vacate the entire building, right, and put them elsewhere. So those sustainable retrofits will have to be carried out while the tenants, the owners are still living in those properties. I suppose the appropriateness are to do with the disturbance caused to those occupants and owners. This is a table or graph presented by McKinsey. They produce a GHG abatement cost curve showing the different sustainable retrofit solutions. So in my team, we also look into different sustainable retrofit solution, trying to look at it from the different areas in the urban area, building in the urban area, for example, those in the common areas and those in the privately occupied areas as well. So those can also be related to different types of retrofit. Some are of minor nature, some are more routine, some are of some major retrofit solutions. So those might require the relevant authority to approve. Different types of upgrading or sustainable retrofit would cost differently and would result in different disturbance. So in the end, we work out a decision model, trying to help out the occupants commission or committee to decide what sustainable retrofit solution they should go for. So we try to look at it from the energy reduction or carbon reduction perspective. We also try to look at it from the cost and disturbance perspective. So in the end, we try to come up with a trade-off model to help them to decide which is the best option for the sustainable retrofit, especially for those multi-occupant, multi-tenants, multi-story high-rise buildings in Hong Kong. Now, the last thing that I'd like to talk about is the more recent development in circular economy. I suppose the circular economy concept is affecting the construction industry quite substantially. Although it seems to a lot of people that it's just a concept, but I suppose this can be realized in future, especially with the more greater application of the modular construction. So in Hong Kong, the Hong Kong government is pursuing the use of what we so-called the modular integrated construction, which is indeed the same as the Singaporean PPVC. prefabricated, pre-finished volumetric construction. So it's no difference to a container with everything made in the factory, fit in the factory, and in the construction site, they simply assemble them together. I suppose the concept of the modular construction is very, very interesting because the use of the material currently is mainly based on the steel structure. And when you think about this modular construction, this is indeed a system approach. Basically, if you want to dismantle those buildings in future, all you need to do is to take those modules away from the building, all right? And those can be taken back to the factory for reconfiguration, for remodeling. So this can save a lot of construction waste. So whereas in the old days, when the buildings are built of concrete, so we still have to build those buildings. But when it comes to the end of the life cycle, basically we have to take them away, put them into the landfill. This is indeed, I think, much circular when we think about the whole concept. I think into the future we probably have to think about how we can make use of this modular construction and build into the circular economy concept, and see how we can make use of the circular material, circular components, circular building, and integrate everything into the design in future. I think I'm a little bit overrun, but I'd like to say, urbanization and decarbonization will go hand in hand with each other. We cannot dissociate them because urbanization is indeed the future, and decarbonization is something that we cannot escape if we want to save the world, save the future of our generation. So we need to adopt a holistic approach from the construction management perspective. From the planning and the design, we need to have policies and clients' requirement, green requirement. And I realized that in the address made by Presidency of People's Republic of China in the United Nations General Assembly, he mentioned that we should focus on the green economy to rebuild our economy after the pandemic. I suppose this set a very important guideline for the world. In terms of how we should use the green economy, including green building, green technologies, to propel the development for urbanization. So low carbon, zero carbon building is going to be our future. And building information modeling is very important because we can make use of the building information model to help us understand the carbon emission of the building, and then help us to perform life cycle analysis, life cycle costing, and so on. The building environmental assessment is also important. In Hong Kong, our building environmental assessment have started recognizing the use of the low carbon material by giving them additional mark, bonus mark in the assessment. I suppose this is going to be the future. So the project delivery stage, green procurement once again, accounting, green accounting, and green assessment. I think all these will have to come into play. Actually, about 10 years ago, I did propose something. Using the green procurement concept. Indeed, the carbon can be represented by a price when we think about the carbon trading. So why don't we integrate the carbon trading concept at the project level and try to make use of the green procurement to reward those contractors who are using green materials? Okay, so this is something that we can think about. So in terms of the construction stage, we talk about the off-site construction, modular construction. I think this can help reduce the carbon emissions significantly. The organizational behavior has to be changed. Still, I think a lot of clients, they still focus on the profit. This is not sustainable. I suppose they should look into the corporate social responsibility as well, and try to help reduce the carbon emission of the world, of the properties. Green and recycled material. And if we go for the modular construction, I think this is also one of the ways to help recycle the materials and the components as well. And currently, we seldom use the, for example, recycled concrete. But I suppose more research in the future will have to be put in place to see how we can make use of all those recycled concrete, recycled glass to put into a new cycle of the construction. Prefabrication, we just talked about. Logistics, green logistics. These days in Hong Kong, we seldom encourage the use of materials from afar because in our building environmental assessment scheme, those materials coming from afar would suffer when it comes to the assessment because those are not considered as indigenous material. Site operation is also important. There's a lot of wastage on site. So in the construction industry, it is notorious for wastage. So a lot of wastage is to do with the rework. If the supervision is not controlled, there could be a lot of rework. So those rework can be up to 5 to 10%. So that means those 5 to 10% of the additional sort of waste will have to be added into the material. So this is not only costly, but also could create a lot of wastage. Construction and demolition waste is something that we have to focus on as well. Demolition stage, there are a lot of discussion or debate about whether to demolish a building or to turn it into better use. For example, once again in Hong Kong, these days people become very environmental cautious. Even an old government building, not that old, right? About 30 to 40 years old, people had a lot of opposition as to the demolition plan. So instead of demolishing the building, this government building has now been turned into a very prestigious hotel. Okay, so people staying in this hotel can get a feel about working in the Hong Kong government because it's a government building, right? So sorting and recycling of demolition waste. One thing that we are looking into is not just the concrete waste and steel waste and so on, but other waste. For example, plastic, because plastic waste is also something that has created a lot of troubles to the planet, including the ocean. Okay, so landfill strategy and policy. Whether we can make use of some of the waste material and turn them into energy. So for example, the waste wood, instead of dumping them into the landfill, can we turn them into energy, okay, without causing too much pollution? So these are all the things that we have to think about. So other thing that we have to think about is the skill set, skill set of different stakeholders. And I think this is very important from the educational institutions perspective. We need to educate our young generation. That's why I think this conference is so important. I understand that there are a lot of participants. Hopefully, the knowledge can be transferred to our students. So in order to build the capacity. So occupancy stage is more to do with the behavior, health and comfort. So whether we can make use of more natural ventilation rather than relying on the things like mechanical ventilation and so on. And Hong Kong has learned a lot of lessons about this urban heat island effect. I hope for the future urbanized cities, high-density cities, those cities will not repeat those lessons that Hong Kong has learned in terms of the urban heat island effect. Building performance should be carefully looked into. So in the UK, the sales of the buildings would get some sort of report for the energy performance. Okay, I think this is going to come. So in Hong Kong, we only perform the energy performance for the commercial buildings, not for the residential buildings. Okay, that creates some barriers for the owners to perform some significant sustainable retrofit to the residential building because there's no incentive. But if the residential building also have some energy performance, of course, if I'm the buyer of this building, I would certainly like to look into those energy performance report before I make a decision as to whether to buy this building or not, or this property or not. The management of the green facilities is something that we have to think about. Monitoring of the life cycle costs. Well, I've heard a lot of stories about very, very good preliminary ranking for the building environmental assessment scheme. But indeed, when it comes to the operation of those buildings, the energy performance is far below those being claimed in the initial assessment. So this is something that we have to look into because the AC system, the electricity system may not be tuned in to its greatest efficiency. So we have to control, make sure that all these building management control systems are in good order, and not to mention about all these green refurbishment. So to conclude, urbanization and decarbonization will go hand in hand in future. So as the policymaker, well, if there are any attending this conference, I hope the policymaker can come up with some pragmatic policy to decarbonize the high-density cities. Okay, so for the building and the industry, building and construction industry, well, we have a lot of things to do to help decarbonizing the existing and the new construction work. And the opportunity for decarbonization exists in every scale, and not just the designer, the contractor, user, and so on, or even the innovators, academic, etc. I suppose everyone has a role to play in help coming up with innovative solution. I think once again that's why this green technology is so important. I think this is a very timely conference. So achieving a low carbon future will require a significant effort to innovate and to enable policies for reducing embodied and operational carbon of the built facilities well beyond what's happening today. So with that, I would like to thank the organizer once again, and hope we will all act together for the future of our children. So thank you very much for your patience and attendance. Thank you.
We know that the way of decreasing carbon emission is of importance for the sustainability of our future generations. Okay. Okay, thank you, Prof. Thomas.
Thank you.
Our next keynote speaker highlights the importance of an integrated approach towards improving environmental performance in manufacturing firms. He proposed a model for the drivers, enablers, and outcomes for this strategy. Critical success factors are also identified that can ensure realization of environmental performance. Dr. Sanjay Mathrani holds degrees in B.Tech Mechanical, Master of Management, and Ph.D. in Information Technology from Massey University. He is the major leader on Engineering and Innovation Management and the Dean for second year BE Hans. He has published over 80 articles in high-quality journals, books, and conferences accepted by internationally reputable publishing houses. His work, published in leading academic journals, include computers in industry, IEEE access, industrial management and data system, and Journal of Enterprise Information Management. Please welcome Dr. Sanjay Mathrani.
Welcome everybody. I hope everyone can hear me and you can see my slide. Okay, so today in my address, I'd like to talk about the current trends in green technology for a sustainable future, and also share with you some research findings from a recent and ongoing study being conducted by one of my PhD students on this topic. But let's start with green technology. So if we look at green technology, we all know that it is the use of science and technology to create products that are more environmentally friendly and then manufacture and supply these products in an environmentally friendly manner. So it is about both the product and the process. The goal is to protect the environment and even repair past damage to the environment. So green technology, also called environmental technology or clean technology, encompasses a continuously evolving group of methods and materials with techniques from generating clean energy to creating non-toxic products in a clean and conserving manner. Some examples of green technology include the technology infrastructure used to recycle waste, purify water, create clean energy, and conserve natural resources. So if we look at green technology, okay, let's move on to the next slide. So there are 5 key goals of green technology. First and foremost is sustainability, meeting the needs of society for the future without depleting existing natural resources. Second is achieving cradle to cradle design and to ending the cradle to grave cycle of manufactured products by creating products that can be fully reused. Third is source reduction, reducing wastes and pollution by changing patterns of production and consumption. Fourth is innovation, that is developing alternatives to technologies, example fossil fuel or chemical intensive agriculture that have demonstrated to be damaging. And the fifth is viability, which is creating a center of economic activity around the technologies and products that benefit the environment. There are 5 R's as elements, or rather 5 steps of green technology: refuse, reduce, reuse, repurpose, and recycle. And let's look at each one of them one by one. So the first step is refuse. Incorporating refusal into one's day-to-day life or as part of a business strategy in a company context is the most effective way to minimize waste. Refuse to buy or use wasteful or non-recyclable products such as plastic bags. In a company context, when working with vendors, refuse unnecessary product packaging and request reusable or returnable containers. Making smarter purchasing decisions and setting standards makes it easier for organizations to refuse waste in the first place. The second step is reduce. Reduce the use of harmful, wasteful, and non-recyclable products. Reducing dependency on these kinds of products results in less waste materials ending up in landfill. Always use the minimum amount required to avoid unnecessary waste, which is part of the lean philosophy. For example, when printing a document, print double-sided to cut your waste output into half. Step 3 is reuse. Examples are renewing energy such as wind power, water power, solar energy, biofuel, wastewater at the macro level. At the micro level, there are many areas of improvement possible. For example, single-use plastics and throwaway culture. The rate at which we consume plastics has become unimaginable. And the plastic crisis has become one of the world's greatest environmental challenges. So in an effort to reduce waste, items can be reused instead of buying new ones. All of the single-use eating utensils such as styrofoam cups, water bottles, and paper plates can be reused with compositable or reusable alternatives. Step 4 is repurpose. So every item that can't be refused, reduced, or reused could be repurposed. Many common office products can serve more than one purpose. Sometimes it requires using some creativity, but the possibilities are endless. For example, using wasted printing paper for scrap paper, cardboard boxes for storing supplies, binder clips to hold power cords, and even mason jars, coffee mugs, and tin cans for holding pens and pencils. And last but not the least, recycle. Recycling is the most environmentally friendly waste disposal method. If your business doesn't already, start collecting cardboard, mixed paper products, commingled materials such as plastics, aluminum, and glass, and other organics for recycling. Some examples of green technology are development of alternative fuels for energy, could be new means of generating energy, to increase energy efficiency and conservation, or renewing energy such as using wind power, hydropower, solar power, geothermal, and bioenergy. Then sustainable management of resources, including water purification, air purification, sewage treatment, solid waste management. Another example could be green building, that is choice of building materials to where a building is located. Then environmentally friendly purchasing, which involves search for products whose contents and production methods have the smallest impact on environment. And then green chemistry, it is application of chemical products and processes to reduce and eliminate the use and generation of hazardous substances. And green technology, which involves manipulation of materials at the scale of a nanometer with application of green chemistry and green engineering. Okay, now let's move on a bit to current research. So from current research, we all know that mankind is facing a critical environmental problem, which is climate change and global warming. And human activities are the primary source of these effects. Industrial operations result in the form of environmental degradation in order to fulfill human advancement. Industries like manufacturing, service, healthcare are facing critical environmental issues with generation of operational and process wastes. Many environmental issues are highlighted as generation of hazardous air pollutants such as carbon dioxide, volatile organic compounds, and other organic and inorganic wastes. So there's a need to manage resources to reduce the quantity and toxicity of waste and materials and achieve the recovery and conservation. Now I'll share a research study that we are conducting currently in which we propose a concept of green, lean, and Six Sigma for addressing the environmental issues in an organizational context. In this concept, green focuses on the environmental performance by using different environmental practices. We just discussed green technology. Lean targets the removal of wastes with the help of its various tools and techniques. And along with lean and green approaches, we also include Six Sigma that minimizes defects and monitors processes through the use of a systematic DMAIC approach. DMAIC is design, measure, analyze, improve, and control. So this slide shows the three manufacturing strategies for environmental performance: green, lean, and Six Sigma, along with their major areas of impact and the key tools and techniques. So green manufacturing is a philosophy to determine, measure, evaluate, and control environmental wastes through green practices such as gaseous emissions, eutrophication, excessive power consumption, and so forth. Lean manufacturing is a commonly accepted strategy to provide value to customers and minimize wastes such as inventory, overproduction, overprocessing, the key 7 or 8 lean wastes that we talk about. And Six Sigma is a methodology in which statistical tools and techniques are used in a systematic and structured way to reduce process variation, defect reduction, root cause analysis. And all of these strategies use specific tools. For example, green manufacturing use the 5R that we discussed just now, life cycle analysis, environmental management systems, design for environment. And lean manufacturing uses tools such as just-in-time, 5S, value stream mapping, total productive maintenance, cellular manufacturing. And Six Sigma use tools such as DMAIC, quality function deployment, design of experiments, and control charts, and so forth. So looking at the synergies of these 3 strategies, we propose a GLSS approach, which is a combination of the 3 concepts, green, lean, and Six Sigma, towards environmental performance in a manufacturing organizational context, in which green focuses on environmental performance and resource conservation, lean focuses on removal of wastes and non-value value adding activities, and Six Sigma on minimizing the defects. So looking at the green manufacturing principle, it focuses on less energy degradation, zero environmental impact, efficient use of resources, environmental and economical advantage, modern technology, zero pollution, and this leads to improved environmental coordination, improved economic advantage, less environmental impact, less resource depletion, and so forth. And lean manufacturing focuses on overcoming the wastes such as overproduction, inventory, transportation, and motion, which have environmental impacts. For example, overproduction leads to more raw materials and energy consumed, extra hazardous materials resulting in extra emissions, etc. Inventory leads to more packaging in storage or work in progress, deterioration or damage of material in storage, etc. And transportation and motion leads to more energy used in transport and emissions, etc. So in lean, these wastes are overcome through the use of various tools and techniques such as just-in-time, JIDOKA, 5S, value stream mapping, total productive maintenance, cellular manufacturing, Kanban, Kaizen, and there are many more lean tools and techniques that are used. When looking at Six Sigma, this focuses on defect reduction, which leads to reducing adverse impact on environmental sustainability through scrap generation, hazardous waste generation, ecosystem damage, and natural resources consumption. But if we look at each of these strategies individually, they have limitations and lack in some respects, such as green focuses on environmental performance and resource conservation, but not on process wastes, which lean does, or defect-free production, which Six Sigma emphasizes. Lean focuses on removal of wastes and non-value adding activities, but not on environmental performance or resource conservation. Similarly, Six Sigma focuses on process control and defect minimization, but not on environmental performance or resource conservation. So if we look at these in dual combinations, 2 together, they still have limitations and lack in some aspects. For example, lean and green focus on waste reduction and environmental performance, but lacks in structured decision-making, analytical and statistical tools, variation control, and ability to remove root cause of issues. Lean Six Sigma focus on waste reduction, process and defect control, but lack in environmental performance and resource conservation. Green and Six Sigma so far have not been considered as a combined strategy because they do not have synergistic focus as per research findings. Now, if you look at this slide, it shows the relationship of these strategies in dual combinations, green and lean, lean and Six Sigma, although each of these strategies have their specific objectives, there is a common overlap of waste reduction in both dual combinations, as we can see from this slide. So if we establish a relationship between these strategies, we can see the compatibility of these strategies by combining them through principles and tools, and then finally leading to a common overlap at the intersection through similarities in natural attributes in terms of environmental impact benefits. Now, this slide shows the different attributes of Green, Lean, and Six Sigma in terms of objectives, concepts, similarities, differences, advantages, disadvantages, and their application. Now, I will not go into details because there's too much on the slide, but these have been mapped into developing a model for Green, Lean, and Six Sigma in terms of drivers, enablers, and outcomes, which we'll see in the next slide. So in this slide, we present a model for Green, Lean, and Six Sigma in terms of the drivers, enablers, and outcomes of a combined strategy. Three different colors depict the three strategies which have been mapped and integrated together. So there are drivers common to all three strategies. So for example, we've got competitiveness, environmental concerns, continuous improvement, waste minimization. Now these are drivers which are common to all the three strategies. Then we've got cost reduction, quality improvement. These are common to the Lean and the Six Sigma strategies. Then we've got individual drivers such as green drivers, which are customer pressure, legal requirements, public pressure, company image. Then Six Sigma drivers, process variation, and lean drivers, achieving customer value in the product, which leads to the enablers. Now, in terms of enablers, due to space constraints, we have coded the enablers. So G1 to G5 are green enablers, L1 to L5 are the lean enablers, and S1 to S6 are the Six Sigma enablers. So the green enablers are the ISO 14001 5R life cycle analysis, design for environment, ISO 50001. Lean enablers are just-in-time, Kaizen, 5S, total productivity maintenance, value stream mapping. Then Six Sigma enablers are the cause and effect diagram, gauge repeatability and reproducibility, design for experiments, control charts, and the DMAIC approach. And all of these drivers, they have impacts and lead into certain achievements such as energy consumption, solid waste management, water consumption, air emissions, toxic waste effluents, and so forth. And all of this finally leads into the outcomes. And so in the slide, we can see there are some outcomes that are achieved from all combination of all the three strategies, such as increase in market share, competitive advantage, customer satisfaction, waste reduction, cost reduction, decrease in environmental fines and penalties. And then we've got some outcomes coming from two strategies such as Lean and Six Sigma, increasing productivity, increasing efficiency. And then there are some outcomes coming from individual strategies such as green manufacturing outcomes, which achieve government regulatory requirements, environmental risk management, waste treatment, environmental process control and regular audits, and Six Sigma outcomes such as sound analytical decision making, effective project management, and also some outcomes from the lean manufacturing. So we have also mapped the critical success factors for a green, lean, and Six Sigma strategy. Now, again, I won't go into too much details, but from the slide, we can see that there are some critical success factors. Now, these factors are common to all the three strategies, such as leadership commitment, employee commitment, tools for environmental performance, financial resources, performance management, measurement, customer relations. And then we've also got certain critical success factors that are critical to some areas, such as employee involvement common to green and lean, government policies, which are part of the green strategy, and so forth. So finally, a critical success factors model is also developed for a green, lean, and Six Sigma approach for environmental performance. So over here in the center, we can see factors such as leadership commitment, information technology infrastructure, customer relations. Now, all of these factors are common to all the three strategies. Then employee involvement is common to the lean and the green strategy. Then we've got individual factors such as government policies, support from financial institutions, which are factors from the green strategy. Then there are some Six Sigma factors such as statistical thinking, project management skills, and project selection and prioritization. So this leads to the final conclusions. A green, lean, Six Sigma approach is proposed towards improving environmental performance in companies. A model for the drivers, enablers, and outcomes of a green, lean, and Six Sigma strategy has been developed. Critical success factors for a green, lean, and Six Sigma strategy are also identified that can lead to the realization of environmental performance. And organizations and practitioners in industry can now better understand the holistic impact of an integrated lean and Six Sigma strategy towards achieving environmental sustainability. So instead of green and lean Six Sigma consultants, which usually are either the consultants are focusing on the green strategy or we have consultants focusing on the lean Six Sigma strategy, we emphasize green, lean Six Sigma consultants, since all of these strategies have synergies between them in contributing towards environmental performance. And for future research, we suggest case studies are being conducted to empirically test the models and capture more insights. Thank you. Terima kasih.
Thank you very much, Dr. Mathrani, for your presentation. And we reach the Q&A session. I'll read some questions from the chat. Prof. Ng, are you still here with us?
Yes, definitely I'm there.
Okay, so sorry. Actually, Prof. Ng has to rush for his next agenda, but let me give you another one question.
Sure.
This is from Samsudin Anis from Universitas Negeri Semarang. He'd like to ask you about carbon emission reduction. We know that there are many carbon material sources, including natural sources from plant and agriculture. How is your opinion for utilization of these materials to reduce carbon emissions?
See, basically what we are proposing in our research is that we should reduce the use of materials that emit more carbon dioxide, such as in process industries, whatever materials are being consumed should be utilized in a more in a manner in which we can conserve these kinds of usage of carbon dioxide. So, I mean, there could be specific methods for conserving carbon dioxide, as is suggested by more plantation in green trees and plants and so forth. But what we are focusing in the presentation that we showed and in the study that we are conducting, that we should conserve by way of using less resources and using less, leaving less carbon footprint in the environment. So the focus should be on waste minimization, waste control.
Okay, thank you, Dr. Mathrani. Prof. Ng? Prof. Ng? Okay, Prof. Ng, maybe he has to rush for his next agenda. Okay.
Okay, thank you.
Actually, optimizing the 5 R's of green technology, is it How is the activity of the method?
So one can go step by step using each of those R's. That means first is refuse, reuse. So if one has a systematic approach of implementing the 5 R's, one can implement each and every R of those 5 R's in a systematic manner to achieve the results that are accepted.
Which one is the most significant?
The last one, if you
The last
see,
one.
yeah, the last one. Let me see. I'll tell you the one which is recycle.
Recycle.
Recycling all the materials in a proper manner, and also reducing. Obviously, there are two which are important: reducing and recycle. Although, of course, we say that all the 5 R's are important, but I would say, firstly, the focus should be on reducing, and then on recycling, and maybe reusing.
Reusing. Okay.
Yeah.
So we have to try optimizing all the materials by reusing it on the way. Okay.
Yes.
Next question from Dr. Suswidayani. She is asking about the substitute paper bags for the food packaging. The use of plastic bag is now tried to be reduced. In the supermarket, we no longer given plastic bag. So
Yes.
How is it? Will it not threaten the safety of the earth and human health, considering to the production process of paper and cloth bags?
So what is recommended is that one should carry your own bags when you go for buying materials or buying, and don't use plastic bags, which is detrimental to the environment. Use your own bags. And if at all required, then use bags which can be recycled or which are environmentally friendly bags.
Okay, thank you very much. Okay, so in the end of the session, we can conclude that urbanization raises many side effects to most of the big cities in the world. Wise considerations are needed to ensure the sustainability of our future generations. The 5 R's is also important to minimizing the pollution, environmental pollution. Okay, I am eternally grateful to having both of you to be our keynote speakers. I hope this conference become an initial of our collaboration between our institution. Thanks again and have a nice day.
Thank you.
Thank you very much, ladies and gentlemen. For the second session, I would like to invite our keynote speakers, Professor Dr. Rizalman, Mamat, and Dony Hidayat AL-Janan, Ph.D. I would also invite Dr. Adi Kusumasiti as the moderator. Without further ado, two moderators, please move forward.
Okay, thanks again. We reached the second plenary session. We have two keynote speakers from University Malaysia Pahang and Universitas Negeri Semarang. Each keynote speaker has 30 minutes presentation. After the two keynote speeches, we will have Q&A sessions. Presenters could post the question in the Zoom chat. Rizalman Mamat is a professor in the College of Engineering, University Malaysia Pahang. He pursued his bachelor and master degree in mechanical engineering, University Teknologi Malaysia. He then pursued his PhD degree in fuel and energy at the University of Birmingham, UK. His major research interests include alternative energy, heat transfer, combustion, internal combustion engine, and computational fluid dynamics. He has published more than 100 Q1 ISI index journals and more than 302 Scopus index papers with Heads index of 43 as of September 2020. He has supervised more than 30 postgraduate students in the field of renewable energy and heat transfer and completed more than 20 research projects. Please welcome Professor Rizalman Mamat.
Yeah, Assalamualaikum and very good morning. Yeah. So we have Alhamdulillah, and I would like to first thanks the organizer from UNES for inviting me again. But now it's very special. We are inviting by online services, yeah, through Zoom. And I'm delighted to see you all again. Yeah, I can see very familiar faces. Yeah, I have visited UNES a few times before. So Alhamdulillah, today I would like to share my experience on working on the biofuels for internal combustion engines. So I would like to share the screen that I have here. Sorry. Oh. Sorry. So is it everybody can see my screen? Yeah. Okay. I hope everybody can see my screen.
Okay. Is it seen clearly? You only need to slideshow.
Okay then. Master Zoom and put it on the slideshow. Okay. Thanks again for attending the conference. I can see that we have a lots of participants. Yeah, although we do it through online, and I'm sure the student and many of the colleagues there in UNES will be enjoy the conference. Yeah. So today I would like to share some information about me myself and the motivation on why I'm going to do some research on the biofuel, and this is one of the important renewable energy resources. But I would like to focus more on the non-edible oil because currently our world biofuel mostly produced from edible oil. Okay, a little background about the university for those who first know this. University Malaysia Pahang is relatively new. Yeah, we established ourselves back in 2002, as compared to UNES. You being there since 1965. Yeah, so University Malaysia Pahang is relatively new. We are focusing on engineering and sciences, and this is some of the important area that we are focusing in. Simply because the university is just located nearby the industry area, especially oil and gas industry, and also automotive industry like the RB Icom, yeah, Mercedes-Benz, Isuzu, all the big manufacturer of automotive are here, just about 5 kilometers to the campus. So about me, my research interest is focusing more on the fuels. We are in the automotive department, and this is all the area that I'm working with on the engines. So mainly is advanced liquid for engines. Yeah. So today I would like to talk about fuel and specifically for biofuels. So the motivation behind this research is quite common to understand that due to the world populations, currently about 7.7 billion, where we have more and more vehicle coming in. Yeah, back in 2018, we already have 1.2 billion vehicles, and the new vehicle sales per year is about 84 millions. Yeah, so you can imagine that years after years, we have more and more vehicles coming in on the road. So the fuel for global vehicles currently use about 40 million barrel per day. You can imagine. This is day by day. All around the world, we are using about 40 million barrel per day. Although the electric vehicle, a very interesting, how to say that, very interesting innovations coming in. But as compared to the total vehicle, it just about 4 million. Yeah. So you can imagine the number of the electric vehicle currently on road are still small, yeah, compared to the internal combustion engines. So whether we believe or not, yeah, I take some of the important, how to say that, important informations, yeah, online. Uh, in 2015 alone, yeah, cars, motorcycle, truck, and bus actually drive more than 3 trillion miles in US, yeah, further than driving to the sun and back 16,000 times. You just imagine the driving length is about 150 million kilometer, yeah, and this is only in United States. What about other country in the world? Yeah, so you can imagine how far we travel, and all this by using petroleum. So what is the real motivation to switch to renewable energy? So whether is it money, is it a global warming, or is it because of the security, yeah? Energy security that makes the world is not stable enough? Yeah. So as you can see on the screen, that the global temperature increase years by years. Yeah, this is due to the carbon emissions. Yeah, and I would like to highlight some dramatic photograph, yeah, taken by Gary Brack. Yeah, he is the actually the journalist and also the photographer. So he tried to connect, yeah, the old pictures, and he go the same place, same time. Yeah, I mean the same years. Sorry, not the same years, the same season, and taking the photo, yeah, and make comparisons. So you can read through the pictures and text in his books, yeah, and also published online. Yeah, his book titled "Earth Under Fire: How Global Warming is Changing the World." So this book is actually published in 2007. Very interesting pictures he took. Okay, back to the world energy consumption. As you can see in this simple graph published by British Petroleum, you can see that oil, coal, and natural gas are increasing years by years. The use of this energy is keep increasing, and this is all from the petroleum, or you can say that this is petroleum-based energy resources. Yeah. Although hydro and other renewable energy also keep increasing, but the ratio is still there, that the oil from petroleum is far, far bigger than the renewable energy resources. But the world is too short now, because back in 2015, it being how to say that, it being predicted that the oil is just will last for 53 years, yeah, to come. So meaning that we have to find new resources, yeah, to replace oil. And as you can see that the world oil production and price is really, fragile. It goes up and down. Yeah, there are many parameters involved. Yeah, the world stability is absolutely change the price and the trend of the oil productions. And this is the data published again by British Petroleum, showing the countries that have the most resources, like Russia, Saudi Arabia, United States, Iran, and China. Yeah. So the alternative energy sources, everybody know that it's we are talking about solar, wind power, yeah, hydropower, tidal power from the sea. We have lots of biomass, especially in the tropical country like Malaysia and Indonesia. And those countries who have the potential of geothermal like Indonesia, we can use a lots of benefit from these resources. So I'm read a lot about the Indonesia's renewable energy, and this is I actually extracted from the Otoritas Jasa Keuangan. Yeah, you can download the document from the website. It is the renewable energy target. Yeah, back in 2016. Uh, and goes to 2050, you can see that the country would like to expand the renewable energy use by 31%. So and currently Indonesia only use 7.7%, about the same amount with Malaysia. So and this is all the specific data and figures. And as you can see that the Indonesia potential renewable energy development, the one that highlighted with the red color is the one that I'm going to talk about today. Although it's small compared to geothermal and hydropower. And this is the data, how to say that, published by the Indonesian government, showing that bioenergy is coming into the third place. Yeah. So this is the geothermal energy in Indonesia. You can see that it is well scattered from Sumatra to Java Island to Makassar. You know, geothermal is quite typical for Indonesian government to explore, and also hydropower. You have all the hydropower station everywhere across the country. Also the wind. Yeah, but the geothermal is how to say that, focus on the Java, Makassar, and somewhere in nearby Bali. Yeah, so because this is due to the geothermal potential area. Yeah. So back to our university, University Malaysia Pahang. I have to, how to say that, appreciate all my team members. So this is all my research colleagues, yeah, working on the biofuels. They are all very young and very energetic guys, yeah, working with me. And we have some postgraduate student also. I should not forget that. And also a master student, yeah, master and PhD student. And this is some of them when we have a regular meeting, yeah, almost every week we have a regular meeting. Sometime every month, sometime every 2 months. So this is all the facility we have on engine. Yeah, we have also tested with many other equipment, but focusing on the internal combustion engine, we have 3 dedicated internal combustion engine, small and big engine. We have diesel. We have diesel, and we have also gasoline engine. And this is all the facilities. Maybe some of you would like, how to say that, an interest to work with us. We are more than happy to collaborate. This is all the facility we have in our laboratory, specifically to analyze the how to say that, the energy on the biofuels, the density, the viscosity of the fuels. We can measure moisture content. We can measure cloud and pour point of the fuels. And even more, we have a central laboratory where we have all the analytical equipment like gas chromatography, liquid chromatography. Yeah, we have also like X-ray fluorescence. Yeah, we have even nuclear magnetic resonance. We have the yeah, gas chromatography. We have PrEP LC, ICP. We have also FISM. We have also SEM and many other equipment. Okay, back to the renewable energy. It is quite common, yeah, currently that many countries in the world try to expand the use of their renewable energy, yeah, to increase the potential of the renewable energy in their own country. And as I mentioned before that we are going to talk about biomass and biofuels. And this is really a good advantage to the tropical country like Malaysia and Indonesia, because we have a lots of agriculture residues like rice straw, corn starch, and many other agriculture residue from palm oil, for example. We have a lot of food waste, animal byproduct, forestry materials. Indonesia and Malaysia produce a lots of timber and wood, so we can use all the waste from these industries to create or to produce renewable energy sources. And talking about renewable energy, this is not a new invention actually, because it's the beginning of the human life. We are using woods for, how to say that, generating heat, and also heat for cooking. So this is some funny picture I took from the internet that's saying also biofuel is not new. It's not really new idea. If those who work in mechanical engineering, you must know this very important innovator, Dr. Rudolf Diesel. He invented the diesel engine that we use until today, but it first patented in 1893, back in 1893. And whether we realize or not, that this engine first actually running on peanut oil. This engine first designed not to work on petroleum, but it designed to work with peanut oil. But at that time, because of the petroleum oil is cheaper, and peanut oil is forgotten, and not just peanut oil, many other oil such as rapeseed and corn oil. We are talking about the European region. We have a lots of other oil, especially in Malaysia and Indonesia. We can have coconut oil, we can have palm oil, we can have many other local oil, that we can use to produce biofuels. So what is biofuel? So biofuel is actually derived from mainly from vegetable oil, and it can be also produced from animal fat. So whatever oil you have in your country, we can convert into biofuel. That's a simple, we call it simple rules. And also not to forget, we can use also any type of animal fat, from cow, from sheep. You can have fat from chicken, from birds. Any kind of fat we can use to produce biofuels. But believe me or not, we can also produce biofuel from other nuts, like cashew, almond, walnut, Brazil nut, pumpkin, cottonseed, hazelnut. We can have many more. This is all the lovely nuts and lovely foods. But sayang sekali bijirin ini digunakan untuk menghasilkan biofuel di setengah negara dunia. Okay, so how we can make biodiesel or biofuels? So it is very easy. You just need two major material, which is oil, any vegetable oil or even animal oil. Like chicken fat, you can cook and get the oil. So with that oil, you just mix with methanol, put in a special container and heat them up to like 90 degrees Celsius. With the help of catalyst, if you have, you can add some catalyst like calcium hydroxide, but you can also just run as it is, oil and methanol. It still works. And at the end, you have two separate liquids. This is methyl ester on top and the glycerol below. So the one that we always refer to biodiesel is on top of this liquid, which is in chemistry, in chemical name is actually methyl ester. But the glycerol down below is, we may call them byproduct. And this is again not a waste. We can use for making many industry product like cosmetics and many others. So this is not a waste. But what we need here today is methyl ester, and this is what we call biodiesel. Yeah. But very interesting to know that the current class of biofuel, we call it the first generation of biofuel. Why it is first generation? Yeah, because currently we are using all this biofuel. The resources is from the food. Yeah, you can see that it comes from sugar crop. We make biobutanol. Yeah, we use oil crops to make biodiesel, and we use sugar and starch crop to produce bioethanol. So all these actually are food. And just imagine that a lot of people hunger in the world, but we are transferring the food into biofuel. So begitu kejam manusia, ya. So the feedstock of the second generations of making biofuel now is different. Yeah, the second generation we are using non-edible oil. Yeah, non-edible oil means oil that we cannot eat. Yeah, just like neem oil. Yeah, if you aware about neem oil, in India they have a lots of neem oil that produce, and this oil being used for, how to say that, untuk apa ya, seperti kalau di Indonesia itu untuk spa, untuk minyak urut, atau boleh juga diguna untuk minyak rambut, ya, neem oil. Kalau di Malaysia buah ini dibilang buah jarak, ya, tapi saya tidak pasti di Indonesia namanya, ya, mungkin sama, namanya juga minyak jarak, ya. Jadi this oil is non-edible, cannot be eaten, ya, but we can use it for the purpose of making biodiesel. So we can have also agriculture waste to produce alcohol. We can use waste oil to produce synthetic fuel. We can use agriculture waste to produce biogas and many others. Yeah. So the idea of having biofuel is quite simple. You need more fuels, meaning that you have to produce more trees. Yeah, more trees, more crops. So meaning that more trees you plant, you produce more oxygen, and more oxygen you produce in the world means good for human being. And the engines running on biofuel is not new. You should not afraid of using them, because a lots of a big brand like Ferrari, Porsche, Mercedes-Benz, and even Maserati have tested their engine with biofuel. Even heavy truck also running on biofuels, including Scania and also ERF. Yeah, even the train also running on biodiesel in UK, in United States, in India and Brazil. And again, not to surprise, even airplane also flying on biofuels. So don't be afraid that even in Indonesia, a lots of apa ya ini, a lot of advertisement, yeah, goes online. I just speak from the website of bsn.go.id, yeah, back in July 2019. Yeah, I mean the government are trying to promote of using biofuel, and B100 means 100% biofuels. Yeah, so because Indonesia and Malaysia produce a lot of palm oil from, of course, palm tree. I don't need to mention the good, the palm oil is the super oil that can be produced. Yeah, and Malaysia and Indonesia produce the major world palm oil. Yeah, in the world, you can imagine these two countries combined. We produce. We are talking about more than 80% of the world palm oil. But believe it or not, yeah, even though we produce a lot of vegetable oil, the country who produce biofuel is not Indonesia and not even Malaysia. Yeah, the country who produce a lot of biofuel is United States and Brazil, and they are using alcohol. Yeah, so both alcohol and biodiesel, we call it biofuels. Yeah, but biodiesel is mainly focused on the biofuel that used in diesel engine, but alcohol is mainly used in petrol engine, like a small motorcycle. Yeah, we can always use alcohol to run on our sepeda motor, ya, kalau di Indonesia. Jadi, although we produce a lot of oil in the world, but we are not producing them, or we are not converting them into biofuel. We keep using it as food, yeah. But just imagine if Indonesia and Malaysia combine and produce all the oil for renewable energy, which is biofuel. This will be the biggest in the world. But yes, both countries are limited the number of the oil to be converted into biofuels due to the food security. Yeah, we call it food security. If we convert all our palm oil into what I call it biofuels, so what what oil we can use to cook the food? Yeah, tidak ada gorengan lagi ya di Indonesia. Kalau semua minyaknya digunakan untuk menghasilkan biofuel. Jadi itu apa ya hasratnya. Jadi the comparison of the price, yeah, palm oil is really superb. It is very cheap compared to many other vegetable oil, right, like rape oil and soya oil. Yeah, palm oil is the cheapest, yeah, more than double, and it produces 4 times bigger oil, yeah, compared to many other oil plantation. Yeah, this is just to compare. If you want to produce, just imagine like the palm oil only use a small area but produce a lot of oil. So we have published a lot of publication. For those who are interested, you can go online and see there are many parameters that we produce to compare a different element like neem oil, jatropha, rubber seed oil, karanja oil, and many other oils. Yeah, and how it affect the performance of this oil. Yeah, so we have published this many times. Yeah, you can go and download yourself if you are interested to know. And we have tested all this fuel. Yeah, mainly from palm oil, from jatropha, from even algae. Yeah, and produce a lots of data and publish in many high reputable journal. So the way forward, yeah, as I mentioned before, the first generation of biofuels are using foods, and this is bad. Yeah, as I mentioned before, that United States and Brazil are converting their corn. Apa ini ya? Kalau di Indonesia jagung ya. Dan di Brazil mereka gunakan sugarcane, which is tebu ya. Semua bahan ini digunakan untuk menghasilkan biofuels. Yeah, just imagine how bad. Yeah, this is all food resources. Everybody love it. Yeah, everybody love to eat corn, potato, sugarcane. Ya, sekarang sudah tengah hari ya. Jadi sudah hampir sore. Jadi ya, ini semua makanan. Ya, yang sebenarnya di Eropah dan di Amerika dan Brazil mereka convert bahan ini untuk menghasilkan biofuel. And as I mentioned before, as good as cashew and almond also being used to convert into biofuel, hazelnut, yeah, pistachio, you name it. All these food are converted into biofuels. Yeah. So I try to put a lots of pictures here, just to make it visible and everybody aware that all these oil and animal fats are currently being used to produce biofuels. So the second generation is quite interesting because we don't need to use all those resources. We can use a lots of other resources like jatropha, yeah, pongamia, yeah. Some this is I believe is Indian roots name, yeah. We call it pongamia pinnata. In India they call it karanja. Yeah, you can use this. This is just a nuts inside that you can convert into biofuel. And believe me, Indonesia and Malaysia also have a lots of this tree actually grow naturally. Yeah, you don't need to plant them. I mean, they just grow, you know, in the bush and in the forest. So we can actually use this all this seed into biofuel. Yeah, jacaranda. This is also a tree that we have a lot in Indonesia. We have tung. Yeah, I put this as a scientific name, which you can find easily in Google. Yeah, but I'm not sure the local name in Indonesia. Yeah, we have kusum, pilu, tamanu, which is sometimes called polanga, jatoba. Yeah, we have a lot of this tree in Malaysia and Indonesia. Tumba, kukuina, yeah, pachira glabra. I saw many in Indonesia when I visit Indonesia. Yeah, spiculia fiotida. We have a small nut like this. Yeah, Crambe abyssinica, small nuts, but still can be used to produce biofuel. Even the small nuts, yeah, of tobacco, yeah, di Indonesia di tembakau ya, kalau nggak salah saya. Ya, Michelia champaca, ya, Garcinia indica, yeah, this is also nuts that we are not eating, but we can use this as a food. Hibiscus subdarifa, some scholar asking me, this is food, yeah, we can use this as a food. Yes, it is. We use this as a food. It's good to make the syrup, yeah, for drinking. It tastes sweet and sour. But what you can use to produce biofuel is from the seed. Yeah, we are not eating this seed actually. Yeah, we are just press the fiber and get the liquids outside the seed actually. And also rice bran. And again, not to confuse, rice bran is not a rice. Yeah, rice is food, but we are talking about non-edible sources. Rice bran is a kind of the a film, yeah, that coated the rice actually. So we are not eating them, but of course, uh, it goes naturally on the rice and we eat. Yeah, but if you how to say that, put them together, we don't eat rice bran. Apricot, yeah, we take apricot to eat, but the seed we just throw it away. So we can use it as resources to produce biofuel. We have trebin seed. This is we have a lot in nearby the beach in Indonesia and Malaysia. Croton oil. Ini zaman anak-anak kecil kita sering main ya dengan buah ini. Saya sering main dengan buah ini ya untuk buat senapang ya, senapang kayu. Jadi itu mainan zaman-zaman anak-anak kecil dulu. And this is Camelina sativa. Yeah, although it's small flower like this, it contains a small seed. If you harvest the seed is like this. Yeah, and you can produce biodiesel from these seeds. And even with cooking oil, we are not eating them. Yeah, after you cook your fries and potato, yeah, we cook some like lele ya, atau ikan lainnya. Maka setelah digoreng, kita tidak consume minyak itu. Jadi minyak ini juga kita bisa hasilkan biofuels. Ya, jadi termasuklah radish oil, orange seed, ya, biji-bijian orange, ya, dan juga eucalyptus oil. Ya, we are not eating this oil, but we are using it for spa and many other minyak urut. Ya. So non-edible sources like many other solid product like wheat, paddy, barley, straw, and bagas. We can use this all to produce alcohol and oil. And even very interesting resources like algae also we can use to produce biofuels. And algae, talking about algae, there are lots of differences available for algae. We have different algae in the pond, ya, di tasik-tasik danau. Kalau di Indonesia banyak sekali danau dan juga laut ya yang mempunyai algae. Jadi kalau dikaji dan di culturekan algae ini, maka lots of potential we can have to produce biofuel from this algae. And this is without doubt that there are lots of studies already conducted and all this oil can be used, yeah, not just for biofuel, but also for other products like pharmaceutical, cosmetic, chemicals, yeah, from algae. So this is one of the how to say that drawing concept, artistic schematics, yeah, for third generations of biofuel produced from algae. Yeah, this is in Colorado. What about this? We can make it bigger and bigger, yeah, to produce algae, and from this algae we can produce biofuel. So again, when we talk about biofuels, currently we are producing a lot, yeah, from food product. Bear in mind that many people hungry. Yeah, there are many people hungry in Malaysia, many people hungry in Indonesia, many people hungry in Africa. So we have to consider that not to convert biofuel from food. Yeah, we have to convert many other seeds, many other nuts, yeah, that we can use to produce biofuels. So I think with that all, thank you very much for giving me this opportunity. Yeah, not to forget that I'm open to any collaboration effort from the audience. Yeah, and again, I would like to thanks a lot. Ya, dari UNES, khususnya Pak Samsudin, ya, Dr. Samsudin yang saya hormati, ya, dari sana yang sering berhubung dengan saya untuk apa jua collaboration antara Universiti Malaysia Pahang dan juga UNES. Jadi sekian dari saya. Wabillahi taufiq wal hidayah. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Okay, we will get back to you after we have the next presentation of our keynote speaker. Okay. Our next keynote speaker will discuss the development of meta modeling and optimization methods, development requirement, and its application. Through its application, it is hoped that the development of the roles of university can be achieved effectively and could support the UNES vision becomes conservation university with international reputation. Dr. Dony Hidayat AL-Janan received his bachelor degree of mechanical engineering, Mamat University of Surakarta, and his master degree of mechanical engineering, Gajah Mada University. He got his doctoral degree from Mechanical and Automatic Engineering National Kaohsiung First University of Taiwan. He has been a lecturer of Mechanical Engineering, Universitas Negeri Semarang from 2006. Please welcome Dr. Dony Hidayat AL-Janan.
Okay, check. Everybody hear me? Okay.
We get you.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, dear speaker and participant in EIC forum. This moment is very honors for me to stand in this special seminar to present my research field in front of you. First of all, I want to say thank you to my dean, Mr. Nur Kudus, for choosing me to this moment, and for all EIC committee that support me very much. And supporting the three previous honorary speaker, I would like to present what I was studying in my doctoral degree that focusing in meta modeling and optimization. This is my outline. The first I want to discuss about human problem need a solution, and second is growing solution with the previous research data. and meta modeling and optimization as prediction, searching better solution. And this is like a sample case for my studying I was studying in doctor degree. And the last is conclusion. Science and technology are developed to meet their science and technology are developed to meet their needs, the human needs. It's developed based on the previous discoveries. For example, the desktop here. The desktop is growing up from the beginner at about 1976, and after that it can, for example, the desktop computer technology. We see clearly that the differences in monitor as media interaction and between human and computer. And at the beginning, the shape is very old and bad. The device is founded with a larger shape with the low brightness, and its developed make the computer have a slimmer form and high brightness in here. So the technology is growing up fastly. But on the other side, because human only focus on his screen, so it's make his body bigger than his screen. And also because the effect of smartphone, we can see that with something, the focus of smartphone, for example, is to make the create the farther closer, but the effect make the human feel farther at a closer. Current technology developed cannot be spared from the previous determination data, so that data is very important to be processed into policy and solution. The data generated from the previous research support the current research. And current technology developed cannot to be separated from the previous determined data, so that data is very important to process into policy and solution. The data generated from previous research support the current research, and but the problem is the true or physical experimental research in laboratory has high accuracy, but has high costs related to human work and other concerns. Therefore, computer simulation based research is now being developed based on the previous research data. To finding the optimal value from the linear equation, or one that is very very simple, like this parameter, we can say that if it is very linear, we can count the optimal like here for this best input. But what happen if the data is look like this? So we can it is very difficult to get the solution or get the result. So how about, and the finding optimal solution if the curve of the real is like this? Sometimes the finding solution is very difficult if the real data is look like this. Finding optimal solution is look like the blind man find the higher hill. because sometimes researcher only get the local optimal here, but the real optimal is in here, or we can call it global optimal. So this only to heal, but what happen if the data is look like this? So it is very difficult to get the good solution. So of course, the blend research or development or researcher cannot find the optimal solution without combining his exploration and his exploitation. His exploration possible get better solution with a longer time, but on other side, exploration exploration possible get the fast solution. Almost the whole of world field need optimization. For instance, in traveling management, the passenger who has several cities to visit within limit time need optimization to determine the visiting sequence. The medical, for the other example is the medical, the doctor should determine the drug for his patient to the disease weak and well healthy background from the giving appropriate medical. It is also like we find in this area in we should be facing the COVID-19 problem and become the pandemic like now. So it's need more data to make some solution about it. And kind of optimization is based of data. We can create the continuous or discrete problem, and kind of problem solve via optimization. The simple method is a system using trial and error. We can make some trial and error, but it is not effective. But, so since 1970, research on optimization is used. Computer is grows rapidly. For optimization rule, there are some require. For the first, we can know about the controlling system. What kind of system we will control? And second is dependent parameter. We should to know about the input. It is very should be very clear. And how about the output? It should be clear also. But if not possible to find the point one, point two, and point three, we can use meta modeling method to predicting the mathematical model or to get the solution. Research of the five or the last is set the optimal solution using optimal optimization method. And for example, the modeling method is regression, is usual use as like a statistical, classical statistical. And number two is neural network. Is the process is look like our brain. By using the studying the data and making some prediction like something like that. And number three is kriging using Gaussian parameter, and is very much number of meta modeling method. And example for optimization method is first is genetic algorithm, like I was used is in my research, and bee colony and cuckoo algorithm is come from the birth of a cuckoo bird, and this come from the model of bee, and frog leaping also. And almost of optimization method are is inspiring by natural processing. And I want to share about what I find in my doctoral degree. For example, here the real problem what I found in my study that in the industry had a problem. The industry had a problem to setting the laser autofocus in glue processing. But the problem is the expert person with trial and error already hired, but the solution wasn't satisfied. So the industry, industry share the problem to us to finding solution. The problem is like this. Sorry. Yes. Okay, this is the, sorry. Wait. Yes, this is the processing of laser. And actually, I've never touched this machine. Even see, I've never seen by directly because the distant limitation. The position of the industrial is very far from our campus. So I just asking my friend to who live close the industry to set the machine based on my recommendation. Yes. So this is based on this problem. I make two solution here for maximal error, and number two is total error. Because the processing is like this, the principle. This is the laser to detect the shape of material. After that is can be make the measurement, and it should be strict on the track. We call it a machine of laser autofocus based tracking system. This is the input. Although this only 3 input here, but the number is very straight and very little. So we should to make maybe it's look like a PID controlling, but the differences effect is very accurate, has a high accuracy about 3 digit after the dot. Propose the so for to find the solution, I propose a uniform design for the first, for to get the 30 training data for neural network, and after that I use 10 testing data to get a solution, to trying the solution. After that 10 again to get a solution. So can I think for the first is after I make the uniform design, using the uniform design to make the for the training data is I use 3 input and 1 hidden layer, and after that is 2 output here for the error. To get the error is the processing of uni neural. And this is the solution I get for the neural network. And after that, this is the solution for the uh, GA. GA. This look like the usual GA using by initial, and after that selection, crossover, and so on. But the special I make some different here because I use uniform design to support or to make the GA search is more better than the usual. And after that, I get the solution, and this is a stand solution here, and it is surprisingly is better than the expert person that hired by the industry. So this is we can see the differences of solution here, and this is come from the expert person, and this is the real data, and this is come from my my algorithm. Is for the first is come from the expert, and this is come from my uh, algorithm, and this is the real condition. So for the conclusion, unineural key result outperform the result from the expert person, also cut the faster rate to 2 days work. So for the first is the expert person need 2 days work to make a solution, but the solution is not good enough for proposing the stand visible parameter. And number 2 is this result prefer the uniform unineural can modify the model or meta modeling use fitness function use, and using UD or uniform design from determining the experiment training data and testing data for neural is highly effective for capturing the predicting the real model and serve controlling with adjustment parameter. And the last is meta modeling and optimization has great possibility to break the limit of physical, because by use this method and in meta modeling and optimization is it can be make not limited in time and an area. Also the maybe if we want to research about the some illness or like a COVID, or also we can use this method because it's not directly to face off the problem. And this method will growing fast and growing with ELT technology, because uh, by day we will make a ELT more. And this is by this research I get the one publication in EEE Access. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for your nice presentation. We read the Q&A session. I read the question from the chat Zoom. Professor Rizalman, are you with us?
Yes. Oh.
Prof. Rizalman?
Yeah. Oh, sorry. My video is not start. Yeah. Okay. Okay. I tried not to interfere the traffic. Yeah. Because I can see lots of participants. Yeah. 267. Okay. Anyway. So
Okay. Okay.
okay.
So we are going to the Q&A session.
Yes.
For your presentation, is we know that palm oil is a kind of edible oil. How do you
Betul.
think about the urgency of using edible oil as non-edible product?
You mean the use of vegetable oil like palm oil to
Yeah,
be used in
for
non-edible products? Yeah.
yeah. For in your case for the
Mm.
biofuel.
Yes. Yes. I think the data has shown that, of course, the majority of the oils, I mean, we are talking about palm oil, is actually produced in Malaysia and Indonesia, used for food. Yeah. In Malaysia, we have the policy by the government that we cannot produce more than 4% of our vegetable oil into biofuels. Only 4% is the limit. So meaning that we produce about 96% of vegetable oil for food. We are talking about other products, yeah, like cosmetics, and believe it or not, yeah, if you go to the market, yeah, if you show many of the food products that are made of palm oil, actually, yeah. There are lots of studies conducted that this oil also can be used to produce a chemical for cosmetics. We are producing also animal products. Yeah, we are also producing a lots of bio resources material like for making sheets and soap. From palm oil. But the amount of these products is not as big as fuels. So we are converting this vegetable oil into this product at the very small scale, compared to the food products. Yeah.
Okay, so
Yeah.
it is still allowable within the limit.
Within the limit, yes,
Okay,
of course.
okay, thanks.
Yeah. Mm.
The next question about the biofuel, especially
Mhm.
biodiesel for diesel
Yep.
engine application.
Mhm.
There is a challenge due to water content in the biodiesel. Could you
Mhm.
please
Yep.
explain about this matter?
Yes. This is without doubt that biofuel have disadvantage, but this is normal. Yeah, when you produce something new, there are good and bad inside. But talking about the water content inside the biofuels like biodiesel, yes, it is, because biodiesel is a kind of hygroscopic material where the water content is high compared to the petrol base. Yeah, but bear in mind that inside the uh, biofuels, yeah, you have extra oxygen, which is good for combustion. Yeah, inside the engines, and the water content itself, yeah, if it is we call it a well blend, as we call it in engineering terms, yeah, in combustions we call it emulsions. Yeah, if the water droplet exists in the fuel as a water emulsion, this give even better effect. Yeah, not negative effect, but positive effect. So you can always convert the bactin exists in this material, which is biofuel, into the good one when we do a lots of research. So I don't think how to say that water content give too much problem until we cannot use it, actually. Yeah, and we have to understand that this engine for 100 years is being designed and used with petroleum oil. So meaning that if now we are ready to use biofuels, we can always modify the current design of the engines. Yeah. For example, when you have the water content, what is the problem? The problem is the corrosion in the pipeline and the fuel tank or whatever. It's about corrosions. So meaning that if you know that we are going to use biofuel for our current engine, So we can modify. For example, you can modify the pipe instead of using the mild steel pipe. You can use the stainless steel pipe, for example. Instead of using the metal tank, we can use a composite or plastic fuel tank. And this is not new. It's already being used by many big brand car like BMW. They are using the plastic type fuel tank. So it's already meaning that we have no problem with the water content inside the fuel when we do a lot of study and make the modification on the engines to be ready, to be ready with the new fuels. And biodiesel is not alone. Yeah, you have so many type of biofuels. Yeah, and so many alternative fuels. Yeah, from waste plastic, from many other resources that needs a special modification on the engine, small modification, and at the end the performance not just similar, even better than petroleum fuel. Yeah, I hope the answer will satisfy the scholars who ask.
Okay, so we only need to modify the material, which is we have to
Yes,
choose the
yes.
material which is
Mm-hmm.
resistant to water. Okay.
Yes.
Uh,
Mm.
Next question from Dr. Ratna Devi.
Mm-hmm.
Could you please suggest how to reduce the production cost of biodiesel, which is always higher than petroleum diesel production?
Mm. Mm.
And
Okay.
then how to ensure the availability of good vegetable oil feedstocks for biodiesel other
Mm-hmm.
than CPU, because the
Okay.
vegetable oil production has not been
Okay.
established well
Mm.
except of
Mm.
CPO.
Okay. Yeah, when we talk about cost, yeah, actually, we always think, when I say we, this is common for Malaysian scholar and also Indonesian scholar. We think that the fuel produced uh, by petroleum is cheaper than we produce oil from a vegetable oil. This is not true, simply because in Indonesia and Malaysia we have a lots of oil in the country. We produce in the country, and we even we call it net exporter of the oil to the world. Yeah, so we are produce more than what we use in the country. So just imagine if you are living in United States and in Europe, the fuel price might go higher, 4 times higher, double than the price in Indonesia. So the oil that we produce from vegetable oil like palm oil is far cheaper actually. And I always say that if we put also we call it subsidy. Yeah, in Malaysia we have a lot of subsidized price for the Malaysians, and that's why we pay much cheaper fuel, even cheaper than in Indonesia. Yeah, in Malaysia. So that's why when we produce biofuels, we say this fuel is expensive than petrol fuel, simply because the petrol fuel is already subsidized. The price that you pay is not the actual price that the total or the average people in the world pay for the same 1 liter. If you put the same amount of subsidy for or subsidize the same amount for biofuel, you will get the cheaper price actually. So I think that there's no issue on that. But the fact that, again, as I mentioned, the limitation of the country, Malaysia and Indonesia, to limit the amount of the fuel produced from palm oil because of the food security, and therefore the price of the oil is you say higher than petroleum. But actually, if you make it apple to apple comparison, you will see that the price is cheaper. And talking about the other sources, yeah, other than palm oil, yeah, in Malaysia and Indonesia we have many other food oil, like oil from coconut. What else? We produce oil from the wheat, Yeah, we produce oil from nuts, other nuts. Ya, kalau di kampung-kampung kita sering hasilkan minyak dari buah kelapa kan. Jadi all this oil we can use to produce biofuels. But of course, because the amount of coconut oil, although you have a lots of coconut oil in Sumatra, but this is still challenge if we convert into biofuels. Yeah, so that's why the second generation of the biofuel, we have to look into the alternative non-edible oil, which we have a lot, and they grow naturally. Just imagine if we pick any of this, put a lot of study in agriculture, how to plant them, how to grow even bigger nuts, how to culture them faster, like what we do with palm oil. We can do the same study on new alternative non-edible nuts like Pongamia pinnata and the rest. If we put a lot of effort to study on how we can do it better, how to grow them better, I think we can produce more non-edible nuts that at the end we can produce biofuels. I think most of the biofuel that we produce in Indonesia and Malaysia now fully export to overseas country, especially in Europe. We are not using it in Malaysia. We are not using it in Indonesia. I mean, we're using it, but not much, because petroleum fuel is cheaper, and again cheaper because of the subsidized price, not the actual price like many other people in the world pay. I think, I hope it answer the questions.
Okay, Prof, it's very clear now. Next question to Dr. Dony. How to define the parameters of meta modeling? Next question to Dr. Dony Hidayat. How to define the parameters of meta modeling?
Okay, thank you for the question, and I want to share about what I'm done before. The meta modeling is make some prediction about the model of the system. So for the predict the parameter is we should to know about exactly in the input and output. So we should to choose the one which one is very has a big effect in this system. For example, for my case, because I just setting the input and this is in the mechanical field, so the input and output is very clear. But if for on the other area, maybe in social or medical, so we should to make a pre research about the to define which one is become the input and output. So is the meta modeling is only the parameter to make it to predict the real condition based on the real result or the based on the real data. After we get the real data, we should to choose one it to become the input and the other and become the output or the effect. After that, we make the meta modeling to make a prediction of model, something like that.
Okay, Dr. Dony, thank you very much.
You're welcome.
We reach the conclusion. The world is now very populated. It significantly increased world energy consumption. It's therefore the application of alternative energy sources is of importance. Meta-modeling and optimization has great possibility to break the limit in physical experiment. Okay, we really appreciate the speech both of you gave to us, which mean a lot for our knowledge. We sincerely look forward to having sustainable collaboration with you. Appreciation also goes to the participants and presenters for spending your time with us in this plenary session. Wishing all of you memorable experience during this EIC 2020. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Prof. Rizalman. Thank you, Mas Dony.
Prof. Rizalman, we are awaiting research collaboration with you. Okay, Prof. Rizalman.
Oh, yeah.
Sorry,
Okay.
you still mute.
Yeah. Okay. Now I'm my voice is there, right?
Okay.
Yeah, I'm more than happy to have collaborations with Indonesian scholars, yeah, professors. Like what I did before, yeah, I traveled many times to Indonesian university, yeah, in Java Island, Sumatra, and I think we are getting closer and closer, yeah, because ya kita cuma serumpun, kan? Jadi kenapa tidak research ini dibuat secara bersama aja, ya? So I'm more than happy. Please let me know. Nanti Dr. Samsudin, ya, Pak Samsudin bisa share mobile phone number saya, ya, for any collaboration works that we can do together, insyaAllah. Yeah, I'm more than happy. Please.
Okay, thank you. I think our colleagues from Department of Mechanical Engineering has visited UMP last year, but this year, due to this pandemic, we cannot travel anywhere. But still, we have collaboration with UMP through the guest lecture program and continued by this EIC conference. Okay, Prof. Thanks again. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much, Professor Thomas Ng, Professor Dr. Rizalman Mamat, Dr. Sanjay Mathrani, Dony Hidayat AL-Janan Ph.D., and Dr. Adi Kusumastuti. Well, ladies and gentlemen, that was the last presentation of the keynote speakers. Next, we are going to have break time, then continue to the parallel session. During the break time, you are not allowed to leave the Zoom room. We are going to break down the presenters into 5 rooms as scheduled. Make sure you have required Zoom account name. Thank you. See you soon, the closing event. Kepada Bapak dan Ibu presenter sekalian, selama waktu istirahat kami mohon untuk tidak meninggalkan ruang Zoom atau meeting room. Kami akan membagi presenter menjadi 5 ruangan atau 5 room sesuai dengan jadwal. Silakan klik join ketika muncul notifikasi untuk masuk ke ruangan room masing-masing. Kami himbau untuk dapat memastikan nama akun Zoom Bapak dan Ibu sekalian sudah sesuai dengan petunjuk yang diberikan panitia. Dan kami mohon tidak meninggalkan ruang Zoom atau meeting room usai sesi paralel hingga acara penutupan nanti. Kami persilakan kepada Bapak dan Ibu untuk bergabung ke parallel session pada pukul 12.30 waktu Indonesia Barat. Terima kasih.
55 tahun perjalanan Universitas Negeri Semarang menjadi pilar kemajuan pendidikan Indonesia. 55 tahun mengantar talenta muda mengabdi di berbagai penjuru persada, menebar nilai konservasi, menginspirasi kemajuan negeri. Dilandasi niat mulia mencerdaskan bangsa, Universitas Negeri Semarang lahir tahun 1965. Ia bermetamorfosis menjadi rumah ilmu pengembang peradaban unggul menjadi kebanggaan Indonesia. Ia selaksa kereta, di mana niat tulus menjadi rel, dan prestasi menjadi energi penggeraknya. Itulah yang mengantarkan UNES dewasa menemu jati dirinya siap menapaki hari baru sebagai universitas berkelas dunia. Secara kelembagaan, sejak tahun 2016, UNES telah dikukuhkan sebagai Universitas Unggul terakreditasi A. Ia juga menjadi rumah ilmu yang diminati anak-anak muda, menjadi peringkat 5 perguruan tinggi paling diminati di Indonesia. Kualitas akademik mengundang pengakuan masyarakat dunia dalam 10 tahun terakhir. Akselerasi jumlah prodi terakreditasi A mencapai 65%. Pada waktu yang sama, lembaga-lembaga dunia mengakui keunggulan melalui akreditasi dan sertifikasi internasional yang diperolehnya. Hasilnya, Universitas Negeri Semarang menjadi ruang nyaman bagi lahirnya cendekia muda berkelas dunia. Prestasi mahasiswa bertebaran dalam bidang akademik, inovasi, kewirausahaan, seni, dan olahraga. Laksana pohon yang terus bertumbuh, semakin rindang, semakin indah, semakin besar kebermanfaatannya. UNES unggul untuk Indonesia maju.
Saya memiliki keterikatan emosional yang sangat intensif kepada UNES. Pertama, intensitas belum emosional itu intensitas intelektual. Kuliah saya hanya di 2, tetapi intelektualitas yang disajikan IKIP waktu itu benar-benar baru saya sadari di hari-hari ini. Bahwa menjadi pintar saja tidak cukup, karena pintar itu teknis. Menjadi orang pintar itu harus sekaligus menyenangkan, itu pendidikan emosional. Nah, cara-cara emosionalitas yang diajarkan oleh dosen-dosen saya itu sangat menyentuh hati.
Kenapa saya memilih UNES sebagai tempat untuk belajar? Karena UNES adalah universitas konservasi dan salah satu universitas yang melestarikan kebudayaan Indonesia.
Layaknya manusia, UNES terus tumbuh semakin dewasa. Peran dan kontribusinya semakin besar bagi Indonesia. Dengan belajar di sini, saya yakin akan semakin dewasa sehingga dapat berkontribusi bagi masyarakat dan bangsa. Kini, esok, dan seterusnya.
Buat saya, UNES adalah salah satu perguruan tinggi yang luar biasa, terutama mampu mengangkat kota Semarang ini di kancah dunia nasional maupun internasional. Komitmen yang luar biasa dari UNES terutama untuk membuat kampusnya menjadi kampus konservasi dan bertaraf internasional. Kalau kita lihat di dalam kampusnya, komitmen itu benar-benar diterapkan. Begitu sejuk, begitu luar biasa penataan estetika kampus, sehingga mahasiswa pasti akan merasa betah, nyaman untuk bisa melakukan kuliah di kampus UNES.
Harum luhuring pawetan ing astoniro. Harum dan luhurnya lembaga ini tergantung pada tangan-tangan kita semuanya. Kami memberikan layanan terbaik dalam tridharma perguruan tinggi agar dapat menghasilkan insan akademik yang cerdas dan berkarakter konservasi. Kami terus melakukan inovasi agar UNES terus menjulang tinggi dengan semangat UNES mendunia untuk Indonesia.
Berwawasan konservasi.
Bereputasi internasional.
Rumah ilmu pengembang peradaban.
Mendunia untuk Indonesia.
Assalamualaikum warahmatullahi wabarakatuh. Saya Rizalman, program studi pendidikan teknik mesin, Fakultas Teknik Universitas Semarang. Program studi pendidikan teknik mesin saat ini terakreditasi A oleh BAN-PT. Program studi pendidikan teknik mesin memiliki visi menjadi program studi yang unggul dalam bidang pendidikan teknik mesin dengan menjunjung tinggi nilai-nilai konservasi dan konservasi internasional. Pelaksanaan tridharma perguruan tinggi didukung oleh sarana dan prasarana yang memadai. Dengan munculnya berbagai peluang dan kesempatan yang ada, maka kampus berharap program studi pendidikan teknik mesin dapat terus maju dan memberikan kontribusi bagi semua pihak, baik di dalam maupun di luar negeri.
Perkenalkan, nama saya Hidayat Ramadhani. Saya saat ini sudah bekerja di SMK Negeri 1 Kutasari, Kabupaten Purbalingga sebagai guru produktif TBSN. Saya memilih prodi pendidikan teknik mesin karena relevan dengan jurusan saya ketika SMK. PTM UNES mempunyai reputasi yang baik. Kemudian lingkungan pembelajaran atau perkuliahan sangat kondusif dan nyaman karena UNES mempunyai visi UNES konservasi.
Perkenalkan, nama saya Hidayat. Saat ini saya bekerja di PT Hino Motor Sales Indonesia. Mengapa saya memilih kuliah di prodi PTM FT UNES? Prodi PTM sudah mempunyai reputasi yang baik. Selain itu juga dengan fasilitas yang ada di kampus UNES memberikan situasi belajar yang lebih kondusif sehingga memungkinkan saya untuk lebih sukses menjadi mahasiswa.
Program studi pendidikan teknik mesin memiliki 15 orang dosen yang terdiri atas 3 orang profesor, 4 orang doktor, dan 8 orang magister dari universitas baik dalam dan luar negeri. Selain memiliki kompetensi di bidangnya, dosen dan mahasiswa Prodi Pendidikan Teknik juga memiliki prestasi yang membanggakan. Kerjasama dengan berbagai pihak dilakukan oleh program studi pendidikan teknik untuk meningkatkan kualitas lulusan dan reputasi, baik secara nasional maupun internasional.
Mari bergabung dengan program studi pendidikan teknik mesin Fakultas Teknik Universitas Negeri Semarang. Teknik mesin, yes I do.
Program Studi Teknik Arsitektur merupakan salah satu program studi di Fakultas Teknik Universitas Negeri Semarang yang berperan menyelenggarakan pendidikan tinggi, penelitian, dan pengabdian di bidang arsitektur. Program Studi Teknik Arsitektur Universitas Negeri Semarang telah mendapatkan status akreditasi B pada tanggal 9 April 2019. Program Studi Teknik Arsitektur Universitas Negeri Semarang merupakan program studi favorit karena jumlah peminat yang tinggi dan cenderung naik dari tahun ke tahun. Sejarah pendirian program studi ini dimulai dari program rintisan kerjasama dengan jurusan Arsitektur dan Perencanaan Universitas Gadjah Mada pada tahun 2000-an. Kemudian program studi Teknik Arsitektur Universitas Negeri Semarang berdiri secara mandiri pada tahun 2010 melalui Surat Keputusan Menteri Pendidikan Nasional pada tanggal 9 Juli tahun 2010. Secara keseluruhan, program studi Teknik Arsitektur Universitas Negeri Semarang telah meluluskan ratusan mahasiswa yang sekarang telah bekerja di berbagai bidang seperti bidang arsitektur dan perancangan, konstruksi, properti, furniture, interior, pemerintahan, dan bidang pendidikan, yang mana lulusan ini tersebar di